Good afternoon, everyone. Today we're going to do a quick video on solving equations with algebra. This would be more of the grade 8 curriculum in terms of the level of equations we're going to be solving. So, for example 1, we have 2x plus 3 is equal to negative 11. So first off, I'm going to start off with the general concept of what algebra really asks of us. Algebra asks us to find the value for our variable. And to do that, what we want to do is get rid of all the murkiness that is tied into our variable, i.e. the multiplication by 2 and the addition of 3. And we want to get x isolated by itself on one side. That's always our ultimate goal, okay? We want to isolate our variable on one side, have it by itself, and have only one quantity of it. Have only one x, one y, one k, one h, whatever our variable is. We want one x, one variable equals blank. And that's going to be our solution, okay? To get rid of any murkiness, to cancel out operations, we always use the idea of inverse operations. And so, for example, if we want to start off by getting rid of the plus 3, the inverse operation of adding 3 would be subtracting 3. And so, let's segue into our first solution. We have 2x plus 3 is equal to negative 11. Now, our first job, let's say, our first task, is to isolate the term with our variable, okay? We want to isolate the term with our variable, namely the 2x term. And so we want to get rid of the plus 3. To get rid of adding 3, we're going to do the inverse, which is subtracting 3. And the first rule of algebra is that we always do the exact same thing on both sides of the equal sign. And so if we subtract 3 on the left, we subtract 3 on the right as well. Now, plus 3 minus 3 cancels out because plus 3 minus 3 is equal to 0. And so that just goes away completely because adding 0 does nothing at all. And so now we've managed to isolate our x term. We now have 2x is equal to negative 11 minus 3. Being negative 14. Now, like we said, we want one quantity of our variable, we want one unit of it, and so we have 2x here is equal to negative 14. We only want 1x, and so here x is being multiplied by 2, that's what 2x means, and so to get rid of the multiplication by 2, we're going to do the inverse of that, which means dividing by 2. We always do the same thing on both sides again, and so we divide by 2 on the left, on the right side as well, and so now x is being multiplied by 2 and divided by 2, and so the 2's cancel each other out. So all we have left is an x. And we have negative 14 divided by 2 on the right side, giving us a solution of negative 7. Okay, and we're done. We can verify that this solution does work for our equation by plugging our solution back into our original equation. And so we replace the x with the value of negative 7. And so we have 2 bracket negative 7, that means 2 times negative 7, plus 3 is equal to negative 11. And we're checking to see if this does indeed hold. 2 times negative 7, that is negative 14, plus 3. And is that true? Well, absolutely. Negative 14 plus 3 indeed states that negative 11 is equal to negative 11, so we know we have the right solution. Okay? So, moving on to example 2, we again want to use our same strategy, or first off, isolating our term with x, our term with the variable. And so here, the term with our variable is the x over 5. Okay? So, if we want to isolate it, we want to get rid of everything else that is alongside it, on the same side of the equal sign. For us, that's the minus 1 here. So to cancel out the minus 1, we're going to do the opposite, the inverse operation of subtracting 1 is adding 1, and we always do the same thing on both sides. Minus 1 plus 1 cancels out. And so now we've isolated the term with x, namely x over 5 is equal to 2 plus 1 equals 2 over 3. And I'll remind you that x over 5 means x divided by 5. And so now x is being divided by 5. We want to end up with simply x by itself, 1 unit of x. And so to get rid of the division by 5, we use the inverse operation of dividing by 5, which is multiplying by 5. To not confuse the multiplication symbol with the x variable, we use a dot for the multiplication. And so we're going to multiply by 5, and we always do the same thing on both sides. And so here we are, and multiplying and dividing by 5 cancels out. And so we end up with x all by itself, and we end up with 3 times 5 on the right side, namely x equal to 15. If we want to check our solution, we can plug it back into our original equation, and so we get 15 over 5 minus 1 is equal to 2. Let's put a question mark because we're checking to see if this is indeed true. 15 divided by 5, that's 3. So 3 minus 1 is equal to 2. Again, question mark. And 3 minus 1, of course, says that 2 is equal to 2. And so we know we have the right solution. And lastly, something a tiny bit trickier, we have 7 minus 4x over 3. Now, our term with our variable is 4x over 3, and we want to isolate the term with our variable. And so let's get rid of the other term. There's only one other term here. So we have a 7 at the start. Nate, I'll just make one note. It's 7 minus 4x over 3, but it's a positive 7, okay? So if we want to get rid of the 7, we have to subtract 7 away, and we always do the same thing on both sides, okay? Now that subtraction symbol is in front of the 4x over 3, and since we only got rid of the 7, that subtraction symbol, or that negative symbol, is still there, okay? And so now we have negative 4x over 3 is equal to 23 minus 7 is 16, okay? Now we still have the task of finding the value of 1x. Here we have the term with x isolated on one side, but we have negative 4 over 3x. Okay, so we have two things to get rid of. We have to get rid of the division by 3 and the multiplication by negative 4. We can do those in either order, doesn't matter. I'm going to go ahead and divide by negative 4 first. The reason I do that is because if we divide by negative 4, our answers for the other side are going to stay smaller. Okay? If we multiply by 3 first, you'll notice right away that we have to multiply 16 by 3, which is 48, not the end of the world, but a little bit trickier to calculate than if we divide by negative 4 first. And so if we divide by negative 4 to get rid of the multiplication by negative 4, then we can do the same thing on the other side. And now we've gotten rid of the negative 4, so all we have left is x over 3. And on the other side, we get a fairly small quotient. 16 divided by negative 4 gives a quotient of negative 4. Okay? And now we have x over 3, which means x divided by 3. So again, to finish off our solution, we want to finish up with x by itself with only 1x left. And so x divided by 3 demands that we multiply by 3 to cancel out the division by 3, and then we do the same thing on both sides. And so we end up with x by itself, which is what we wanted. Negative 4 times 3 is negative 12. And there we have it. Okay? One last time we can verify our solution, plugging our value for x back in. And so we have 7 minus 4x, so 4 times 12 over 3 is equal to 23. And let's check to see if that doesn't dehold. So we have 7 minus 4 times 12, that's 48 over 3 is equal to 23. Question mark. 7 minus 48 divided by 3, that's 16. I'm so sorry. That's a negative 12. Great example of how easy it is to forget a negative. X is negative 12, excuse me. So let's put in negative 12 for a value of x. And so 4 times negative 12 is negative 48. Okay. And now we have 7 minus negative 48 over 3 is negative 16. I could have edited this out, but I think this is a great example of how easy it is to forget our negatives, so always be very mindful of that. And lastly, we have 7 subtract negative 16. Subtracting a negative is the same as adding that quantity, and so 7 subtract negative 16 acts as 7 plus 16, and so we get 7 plus 16, 23 is equal to 23. Indeed it is. And there we have it, okay? So I hope this was helpful. I hope you guys got to see the idea of using inverse operations to first isolate the term with a variable, and then getting one quantity of a variable, 1x is equal to our solution, okay? We've got a few negatives in here, we've got a fraction in here. We have to verify solutions by plugging our solutions back into our original equation. And so I hope this helps. I hope this clears some things up. If you have any questions, comments, suggestions, please let me know. Any questions for future videos are always appreciated, and thank you for watching.